Okay, so we're going to have a look what happens when an alpha particle has a head-on collision with a gold nucleus, and we're going to talk about this idea of distance of closest approach. For this one, we're just going to be looking at energy, considering energy. Okay, so we've got the alpha particle there. It's whizzing along to the right, and it's got lots of kinetic energy at this point. But obviously it's positive, plus 2e charge, and the gold nucleus got a plus 79e charge there. So these two are repelling each other, electrostatic repulsion. So what happens is the alpha particle starts off and it's going towards the gold, but it's getting slower and slower and slower and slower and slower and slower until it stops. So at this point here, it has stopped because of this electrostatic repulsion. So let's just put that in here, represent it with this double arrow. They're pushing against each other and it gets brought to a stop at this point. Obviously, well, I say obviously, it's not going to stop there forever because of this strong force pushing against it. So if I just cheat and drop it down a bit to help my diagram, then this force here, this repulsion, is going to push it away again. So then it's going to gradually accelerate and it's going to get faster and faster and faster and faster. So it's going to end up back over here. And what's going to have happened? Well, it's energy. The energy cannot be created or destroyed. It can only be transferred. So the Ke here has gone to electrostatic potential energy here. It's energy stored in this field. Think of this electric field as like a miniature spring almost, and as the particle approaches, it's squashing this here, this field, it's squashing, and you're getting more and more energy stored in this field, and it's called electrostatic potential energy. It then, of course, pushes the alpha particle back, so the alpha particle then gets EPE, electrostatic potential energy, is changed back into kinetic energy. But the bit we're interested in is this. If we mark the middle of the gold nucleus and we mark again this point where it stopped, then this distance here is D, the distance of closest approach. And in the next video, we're going to look at some maths. We're going to do some calculations on energy to enable us to calculate this distance D. Okay, thank you for listening.